About making a Sokoban game. In Sokoban games, you push boxes around in a grid to try to get them into their correct location, and typically in a level that's so small that it turns into a puzzle game. So I have a player object, a box to push around, a wall to stop the player, a marker object I can use for object picking, a floor for the background, and goals, spaces that I want to push the boxes to. If I go to the events, we'll start with movement. In this case, I'm not using the built-in top-down behavior because I need a very specific kind of movement. So in this example, I have a variable for X move and Y move that I'm going to use to tell the player to move up, down, left, or right. So if I press the A key on the keyboard, it will change the X move position to -64. So we can tell the character to go left 64 pixels, which is the width of the player object and the size of our grid. And we do the same thing for the other key presses. Now these don't need to be key presses on a keyboard. I could put on-screen controls into the game scene and use that to control the character on a mobile device. And then if I go down, we'll see how we're using those variables. So if the variable for X or Y is not equal to 0, which means we press one of those buttons, we'll create a marker object on the player. And then with that marker, using a while event type, which you can get by right-clicking on an event, going down to add other, and finding while. And you need to be careful with this kind of event, because if the condition stays true, your game will freeze and it won't render the next frame. So for this, if the marker is in collision with an object from the object group that I'm calling objects, which is both the box and the player, then change the text variable direction of that object to move, and change the position of the marker to equal the marker's position plus the X and Y variable. So if I pressed the D key, the marker will spawn on the player, change the player's direction variable so it says move, and then it will change position to be 64 pixels over, into the next square on the grid. And if there's nothing there, then this condition is no longer true, so it will move on down the event sheet. But if there's a box there, it will do the same thing it did to the player. Change the direction variable to move, and then move the marker over again. And if there's another box, it'll do the same thing, and it will keep hopping down the line until it's no longer in collision with an object from the object group. So when the marker finally gets to a point where it's not in collision with an object from that object group, we check if one of these conditions are true. If the marker is in collision with a wall, or if the marker is in collision with a goal that has its animation changed to filled. So if I go to the goal object, you can see that its second animation is filled, and it's a box. Because when you put one of these boxes onto the goal point, it'll delete the original box and change the goal to filled, which will then act as a block that will stop it from being pushed through. And if it's in collision with a wall or a goal that is filled, we delete the marker, and then pick all objects and change their direction variable back to none. And that way nothing happens. So the marker will hop through the objects, hit the wall, get deleted, and then change all of the objects back to none. But if the marker still exists and it gets past that event, this time, we're still going to change the object back to none, but before we do that, any object that had its text variable changed to move has its position changed based on the X and Y variables that we changed above. So we check which ones were tagged to move, change their position, and then change them all back to none. So a quick recap, when there's no box next to the character, and we tell it to move over, it creates the marker on the character, and then the marker moves over one tile. Because it's not in collision with the wall, or a goal that's filled, it will move on, see that the player has its object variable changed to move, and then add the X and Y coordinates to that of the player, and then change it back to none. But if there's a box there, that marker will hop along the boxes until it gets to a point where it's not in collision with the player or boxes. And if that point isn't a wall, or a goal that's filled, all of those objects that were tagged to move will move over, and then get set back to none. But if there was a wall there, all of the objects will be set back to none without being moved. And then, if a box is over a goal object, and the animation of that goal object is empty, delete the box, and change the animation of the goal object to filled. So now, that goal object is going to act like the wall. And then, once all of that is done, we reset the scene variables for X and Y to be 0. So they're not triggering that above event anymore. And then the game is won when the number of goal objects with the filled animation is equal to the total number of the goal objects in the scene, at which point we show the win layer. And then lastly, if you mess up and need to restart, we're using a custom button object, which can be found in the asset store, and then using its condition is clicked. We change the scene to the current scene, which is an expression you can get by typing scene into the expression builder. Now if you like tiled-based games, then you might be interested in this video where we show how to do the basics of a city builder game. Let's talk about creating a tile-based city builder in GDevelop. The basics are actually really easy to do. So if you've ever seen a game like Islanders or SimCity and wondered how you could do something like that in GDevelop, then stick around. First, starting with the indicator object, which has 3 different named animations related to the types of objects being placed in the game. And its collision mask has been changed to the center. And I've got that placed in scene, but out of camera view. And then we have these 3 custom button objects that you can get by going to the asset store and finding the menu buttons asset pack. When you download one of those buttons, you then have the object type and the custom logic in your game. And you can just swap out the images and change the values to fit the kind of tile you have. And then we have 3 sprite objects that represent the 3 different kind of buildings we're going to have in the game. A house that will give you gold, a mine that will give you stone, and a lumber mill that will give you wood or lumber. And then we have 3 text objects that we'll use to display how much of each resource that we have. And for those resources, we have 3 scene variables, gold, stone, and lumber, and they'll be displayed on screen. For the events, which begins by changing the position of the indicator object to the mouse's X and Y position, and then snapping that indicator object to a hexagonal grid, using the size of the image, and then snapping that indicator object to a hexagonal grid, using the size of the image and 2 offset values that you'll need to figure out based on the kind of tiles that you have. And you get that action after you've installed the hexagonal grid extension. And if you want to use a square grid, there's an extension for that as well. Next, we have an event that changes the text objects to display our resources. So for each one, it's in quotations the resource name plus the variable. Next, in order to pick a building type, we have this event, where if the indicator is hidden and not visible, so nothing's been selected, and we click on one of the icons, it shows the indicator, and then changes the animation of the indicator object to be the same one as the icon we picked. So if it's the house icon, it'll change to the house animation. And then to actually place the buildings, we have this event, where if the left mouse button was released, and the indicator object is not in collision with the tiles group, which is a group that I made that has all 3 different building tiles in it. So if it's not in collision with any of those buildings, and the indicator is visible, then we check to see what animation it's set to. So if it's set to the house animation, we check to see if we have the resources required to build the house. So we see if the stone and lumber values are greater than or equal to 10, because in this example the house costs 10 stone and 10 lumber. And if those values are above or equal to 10, then we subtract those from the variables and create the house object at the X and Y coordinates of the indicator object. And we do the same thing for the mine and lumber mill, with the only difference being that the requirement for those is gold instead of lumber and stone. And then to hide the indicator or deselect your pick, if the right mouse button was released and the indicator object is visible, hide the indicator object, which means we can't buy a building, but we can select a new icon. And then finally, in this example, each building will give us some value over time. So at the beginning of scene, we'll create the scene timer called income, and then if that timer is above 1 second, we add to our resources by adding the number of those buildings that exist in scene, which is an easy expression to get with the expression builder because you just type in instance count, select that option, and then tell it which object you want to check. So if we have 3 houses laid down, we'll earn 3 gold every second. Now this is a really simple city builder. If you'd like to make something a little more complex, there is an example in Engine called City Builder that includes some more advanced mechanics. I'll put the link to that one in the description. But even this simple city builder can be made to be more fun with just a little bit of game juice. And if you'd like to learn more about that, check out this video.
Hi, Max here. In this video, we'll be covering the platformer example. By the end of the series, you'll have a full platformer, complete with enemies, moving platforms, checkpoints, and everything you can see right now. If it's your first time in GDevelop, we recommend you check out the official intro tutorial series. We'll be glossing over some of the basics since we covered them there, so you should definitely watch those if you haven't already. Finally, you'll find all the assets in the description if you'd like to follow along. There's also a text guide if you prefer that to video. So, with all that being said, let's get started. So, after starting a new blank project, the first thing that we want to do is tweak some of the game settings. The assets are designed for 960 by 540, so that's what we'll go for. So for the next part, we're going to be talking platformer basics. We already have a video on this, so I definitely recommend checking that out if you haven't already. We'll start by creating 4 simple sprite objects, which are just going to be our 4 platforms. We'll want to give each of these a platform behavior, and we'll go ahead and disable ledge grabbing. After we've done this for all the platforms, we'll add another sprite object, which will be our player. Then we'll add our 5 animations: idle, run, jump, climb, and fall. To match the source frame rate, change the frame time for the climb and run animations to 0.04, and also set all our animations to loop. We'll give the object a platformer character behavior. There's a lot of settings, and I encourage you to experiment with them. I found the best results with a jump speed of 650, max falling speed of 500, walk acceleration of 1125, and a max walk speed of 200, with all other settings left as default. Then we can build out our stage and place our little platformer character. Now we can move around and interact with platforms, but there's a couple problems. For one, there's a bit of a gap between the player and the platforms, and perhaps more noticeably, the player does not have any animations. We'll tackle these issues in order. The gap issue is due to collision masks, which we can edit using the Edit Collision Masks button. We'll want to use a custom collision mask and then configure the points to better match the actual texture. For some textures, like this one, you might need to use the Add a Vertex button in order to have more geometry to work with to better match the texture. You'll want to do this for all of the platforms as well as the player object. That solves our gap issue, but of course we still need animations. For this, we'll dive into the events, and we'll check for when the player is moving. Then we'll make a new sub-event and check for when the player is on the floor. Then of course, if the player is on the floor and moving, well, we want to play the running animation. We can repeat this for the jumping and falling animations. And then to test being idle, we want to know when the player is not moving. Then we just need to check when the player is on the floor, and then set their animation to idle. Then we'll check the direction of the player, and then flip them accordingly. So when they press left, you flip the sprite, and when they press right, you unflip it. Now our little guide looks a lot more alive. As a quick tip before continuing, I'd recommend using the event groups to keep your events nice and organized. So in this case, I'll create a player event group and put all the events we've done so far in it. This might seem tedious, but trust me, if you keep up with this, you'll thank yourself later. Finally, as a last little touch, we can add a sound effect when the player jumps. To do this, we'll first check if the player is jumping, and then we'll use the trigger once condition to ensure that the sound plays only once when the player jumps. Finally, we'll use the play a sound action, and the game now has jump sound effects. Next, we'll add a score and coins system. We already have a video which goes over this setup, so I recommend you check out that video if you're a bit confused about this next section. We'll start by making a coin sprite object, and then we'll also make a text object for our score display, and we'll also add a new UI layer and add our text to that layer. We'll add a scene variable for the score. Then when the player collides with the coin, we'll delete it and add 1 to the score. We'll also need to update the score text to be accurate, and we can finally play a sound when we collect the coin. Next, we'll deal with player death. First, check the Y position of the player. And in this case, we're going to check if it's greater than 540, which is the screen height. If this happens, the player is off the screen, and therefore dead, which means we can teleport them by setting their position to the spawn point. In this project, the spawn point is 200, 275, and I got those numbers by checking the position property of the player. And of course, we can also play a sound when they die. Now our player will properly respawn when they die. Now to tie up this video, we're going to change this dull gray background to something a little bit more interesting. We'll create a few tiled sprites. One is for the background plants and the other is for the clouds. And we can also add a simple moon sprite as well. Then we can add our background plants object and scale it. Of course now the background is layered above everything, which we don't want. And we can fix this by creating a new background layer, which we place under our base layer. We'll also create a foreground layer, which we place above the base layer for our clouds. Then we can adjust the layer of our background and add our moon, set its layer to background as well, and then we can add and resize our clouds and add them to the foreground layer. Looks much better now, don't you think? That wraps up the first platformer tutorial. Definitely catch the next video where we'll go over enemies, ladders, and moving platforms. As per usual, we'd love to see your feedback in the comments below, so let us know what you want to see next. Thank you so much, and I'll see you in the next one.
Hey there, I'm Helper Wesley, and this video is part 2 of our platformer example. So in the last video we went over character animations, platforms, the background, and so on. This time around we'll be starting with some basic enemies. So I have a sprite object here, that's a fly. If I put it into the game and then preview the game, you'll see that it's just sitting there. But if I go to behaviors for that object and search for rectangular movement, we can install that behavior. And then when we go down the list of installed behaviors, it'll be there. This behavior can make an object move in a rectangular path. But in this case, we're going to use it to make the fly go up and down. So we're going to turn the horizontal speed and distance to 0. And then we're going to give it the shake object behavior. Again, you can find this by searching in new behaviors. And now we can go to the event sheet to make it interactable with the player. So we'll start with a blank event, where if the player is in collision with a fly, and a Boolean variable, which is just a true-false variable, called dead of the fly object is false, one time, the fly will be killed, if the player is falling when the collision happens. In which case we set the Boolean variable to true, and then to make the character bounce off the fly, we add a sub-event with the actions allow player object to jump again, simulate pressing the jump key, and then play the jump sound. And then for the gameplay itself, we can make this add to the score by just making another sub-event and giving it the action change the score by adding 50. And then finally, we're going to make the fly fall out of the sky by deactivating the rectangular movement behavior, adding a permanent force to the fly to make it fall down, and then use this action from the shake object behavior that we installed to give the fly a little shake as it falls down. But alternatively, if the fly hits you and you're not falling, we'll set the Boolean value of the variable dead for the player to true, and that'll be used to trigger the death event made in the last video. And then finally, it's a good practice to get rid of objects that fall out of the screen. So when the fly's Y position is lower than 540, which is the bottom of the screen, we'll delete the fly object. And now to see that in practice, when we jump and land on the fly, because we're falling, it stops its rectangular movement behavior, and then falls at the applied force, and shakes a little bit as it goes down. And then once it goes beyond the screen, it gets deleted. And now if we try that again, but let the fly hit us while we're not falling, we'll die and get sent back to the start. Next, we're going to add in this static creature that catches on fire. So the first thing we'll do is set it to turn its fire on and off based on a timer. So at the beginning of the scene, we'll start the timer called fire of the monster object. So this is an object timer. And then next, if that object timer is above 2 seconds, toggle the Boolean variable called fire of the monster and reset that timer. Next, to change the animation of that object based on the Boolean variable, we'll create 2 events. The first being if the Boolean variable is false, then change the animation to the animation named not fire. And if it's true, set the animation to the animation named fire. And then give both of those events trigger once. And now the enemy will change animations based on that timer, going back and forth from being on fire to being not on fire. Next, we'll set up the events for what happens if the player collides with that creature. So if the player is in collision with the monster, trigger once, with a sub-event that the animation of the monster is set to no fire. Then we break it up into 2 sections. One for if the player is falling, so they're falling on top of the monster. Do what we did for the fly to allow them to jump again and add to the score. But instead we're going to delete the monster this time and create a particle effect at the center point of the monster. To learn more about particle effects, check out our video on particles. And then the other option is if the player collides with the object and they're not falling, in which case we'll set their Boolean variable dead to true, sending them back to the start. And then finally the last option for when the player is in collision with the monster, but their animation is fire, then the player will die regardless of whether or not they're jumping on top of them. And this is what that looks like in practice. And finally with this, to make these deaths work with the Boolean variable, we needed to modify the events from the last video. So now whether the player falls off a cliff, or runs into an enemy, or something else, we can change the Boolean variable dead to true, and that will trigger this below event, which will set it back to false, then move them back to the starting position, and play the death sound effect. Hopefully you found this video helpful. We'll be building onto this example in the next video, where we're going to explain a few more things, like the checkpoint system, and whatever else didn't get explained in these first 2 videos. As always, be sure to comment down below, and tell us what kind of tutorial you would like to see next. I've been Helper Wesley, and I'm glad I could help. Hey there, I'm Helper Wesley, and this is the 3rd video in our Example Platformer series. In the last video, we finished with this. We had some platforms, a background, some enemies, and coins to pick up. But of course we want to make this bigger than one screen. So, we need to expand the background and foreground objects. And then we'll add some more objects. For a simple camera, we're going to use the Smooth Camera extension. And then we need to add it as a behavior to the player object. There are a bunch of useful options in here, but we're going to leave those alone and just uncheck the follow on the y-axis checkbox. And now if we preview the game, you'll see the camera is smoothly following the character along the x-axis. And for these moving platforms, we've just given them the rectangular movement behavior, like we did with the fly enemy. And then to create a more interesting background and foreground, we want to add a little bit of parallax. And the simplest way that I've found to do that is using image offset. And this only really works for tiled sprites. So we set the x offset of the background object to be equal to the camera x position divided by 3. So it'll move slower than the camera. And then we set the x offset of the clouds in the foreground to be set to the camera x position times 1.1, so it'll move a little faster than everything in scene. And this is what that looks like. But next we're going to put down some boundaries in our level, so the player and camera won't go beyond a certain point. So what I have here are sprite objects with a transparent square image as their animation. And I have one for left, right, top, and bottom of the screen. So I'll just put those all in place, where I want the scene to start and end.
And you can see that these all have the platform behavior, so the character can't go through them. And now if we go to the event sheet, to make this work, we need to add the action enforce camera boundaries. And for the positions of this, we're using those objects. The left boundary, right boundary, bottom, and top. But for the left and top, you need to add their width and height, so you're getting the innermost edge. And now if we preview that, you'll see that the character and camera stop at this point. And then to make sure that those don't show up on screen, we hide the group of objects called helper objects. And if we go to our object groups, you'll see that the left and right boundary are in this group. Next, we're going to add a ladder. This object has the platform behavior and is set to ladder. And as you can see, we've given the player character a climbing animation called climb. And so if we go to the event sheet and look at how the animations work, you can see that from the last video that we've slotted in 2 more events. One where if the player is moving and is on a ladder, set the animation to climb and play the animation. Whereas if they're not moving and they're on a ladder, pause the animation. And you can see what that looks like. You can go up and down the ladder, and when you stop moving, it stops playing. But the problem with this is that when you get to the top of the ladder, so I have another sprite object here with the jump through platform behavior. And we're going to put that down on top of the ladder. And now the character is able to stand on top of it when they get to the top of the ladder, and can drop down by pressing the down key. The reason you can't see it is because it's a part of the same group that we hid with the borders. Next, we'll go over the checkpoints. We'll put some of these into the scene. And as you can see, it has an inactive, active, and also inactive animation. And it has an effect that is the adjustment type, which lets you change some visual things about the object. In this case, the saturation, which is set to 0. So when the game starts, it'll start off as gray. And to do this, we're going to use the extension checkpoints. So if we go to the event sheet, we can see the checkpoint setting event. So if the player object collides with a checkpoint object, we'll play a sound, and then pick all checkpoint objects and set their saturation to 0, and set their animation to inactive. And then the event below, that is picking only the object that we're colliding with, set its saturation to 1, change its animation to active, and use the action save checkpoint, with the object being the player, and the X and Y position being the X and Y position of the checkpoint. And then we'll give it the name player position. And then at the beginning of the scene, we do the same thing, but instead use the X and Y position of the player as the starting checkpoint. And then for the player's death, we've replaced the move to a position action with the move player to the checkpoint action. And this is what that looks like. You'll see that when a new checkpoint is activated, the old one deactivates and gets desaturated. And then when you die, you go back to whichever one was last checked. Next, we're going to create an end screen, so that in this level, when you get to the end, this end screen will pop up and let you restart the game. So first we need to add a layer and call it end screen. And then we have a sprite object that we're going to use as a darkening layer. And then we'll put some text objects in there to say, congratulations, you got this many points. And then if you got the highest score possible, we'll display this text. But if you didn't, we'll display this one. And we'll put those over each other so that we can hide the one that we don't want. And then finally, a big bold text for the retry button. And we need to make sure that these are all put onto the end screen layer that we created. And that way, if we hide the layer, we hide everything. So to make this work, we need to look at our events, where if the player collides with the portal at the end of the level, we change the black background to have a lower opacity so you can see through it, show the layer end screen, and deactivate the player's platformer behavior. And then, if the end screen layer is visible, we trigger once these below events, starting with modifying the text of the end screen subheader that tells you how many points you got. We have you got, in quotations, plus the variable score, plus points, in quotations. So we have two sets of text and a variable in between, combined together with plus signs. And then, based on what the score they got was, we hide whichever one of the text objects says that they got the max score or could do better. And then to be able to restart the game, we have the retry text object. And to make it obvious that you're supposed to click on it, we've set it up so that when your cursor is over the object, it starts to shake the object. And when it's not over the object, it stops. And then finally, if your cursor is over the retry text object and the left mouse button is released, we change the scene to the current scene to restart the level. And that is a lot of information, but this is what that looks like. We show the layer, darken the background, display the score variable in between that text, and then if we hover over retry, it'll start shaking. And if we click on that, the game will start over. This brings us to the end of the platformer example series. So be sure to comment down below and tell us what kind of example series you would like to see next. And please, no one ask for World of Warcraft. I've been Helper Wesley, and I'm glad I could help. Hey there, my name is Helper Wesley, and today I'm going to be recreating asteroids. I won't be showing you how I'm creating these events, just the ones that I'm using, because I'm assuming that you've gone back and watched the rest of the tutorials that we've made, but I will be showing you what I'm doing. So to begin with, I'm going to be using the Space Shooter Redux pack, and I'm going to jump right into a blank game project. I'll create a new scene, and I'll create a sprite object named player. For this example, I'm going to take advantage of the physics behavior that comes with GDevelop by default. And I'm going to start by leaving everything alone except for changing the gravity to 0, so that the object doesn't just fall out of the sky. So now we'll move over to the event sheet and start with a player movement, with the condition if the W key is pressed, and then the action apply a physics force towards the angle the player is facing. And then I'm going to move the origin of the sprite into the center so that we can use that origin point as the point where forces will be applied. And then we'll copy our condition for our first event, and then paste those for the A and D key presses, and then we'll apply a torque to the player object based on which key is being pressed. Take note, this is not just the rotate an object action, this is apply a torque. It's specific to the physics behavior, and I'm using this because I want to make sure that all of the forces are being applied using the same kind of rules. And now, I have a character that spins out of control. The problem here is that the sprite is in the wrong orientation. So I'm going to open up Piskel, change its orientation, and then save it. With that part fixed, I'm going to move on to firing bullets, using the conditions when the spacebar is released, and once. And as you can see, I've created the bullet object already. And since the bullet is a really bright color, I'm going to change the background of the scene to black, so it stands out better. And now for the bullet, we put the action create object, and add a force, and rotate object. But moving the rotate action above the apply a force action because we want to make sure that it's rotated before it starts moving. And the bullet's orientation is off, just like the player's was, so I could go into Piskel and change the orientation of the bullet just like I did with the player, or I can add 90 degrees to the rotation and change it so that the player's angle is the thing that tells it which direction to go. And after we tweak the origin of the bullet, just like we did the player, it works just fine. Though I do have to change the Z order so that the bullet spawns below the player and not on top. And that's the player basically done. Next we'll make another event for the beginning of scene, where we're going to change the center of the camera to the 0 point and change the zoom to 0.5. Changing the camera to the 0 point was so that we could easily do screen wrap, and zooming the camera out was just so that we would have a better scale for an asteroids game. Now let's add some asteroids. We'll add in some animations, and give them the physics 2.0 behavior, place a couple in scene, and we'll do that again with medium and small asteroids. And now because everything has the physics behavior, I can start knocking things around like marbles. And just like in asteroids, we're going to make it so that when you shoot an asteroid, it blows up into smaller parts. So we'll create a for each instance event, where the object being picked is the big asteroid, use the condition if bullet is in collision with asteroid, then we will create 2 medium asteroids, give them a random rotation, and then apply a force in whichever direction they're facing. And then we delete the original asteroid and the bullet. And then we do that 2 more times, with the only real difference being that the small asteroid doesn't spawn anything, it just gets deleted. We're getting pretty close to this being asteroids. We're just missing a couple of things. The most noticeable one is the screen wrap. So we're going to create a for each instance event, and for the object picked this time, it'll actually be the group everything, because I put everything in one group. This game's resolution is 800 by 600, and because we moved our camera to center on 0, then we can use this condition if an object in the group everything goes beyond 800 in the x direction, or goes behind negative 800 in the x direction, then it will have its x position times by -1, which will flip it to the other side. And then we just do the same thing for the y direction. And now we're almost there. The last thing that's needed for this to be a game is a fail state. So we're going to go to the project manager and look for the extension health. We'll add that to the project, and now I'll go to the player and select health, giving it 3 as its total, and a 5-second cooldown until it can be damaged again. Then we'll create a tiled sprite, and call it lives, place it in screen into the default border of the camera, putting it onto the UI layer that I made earlier, and then we use the physics condition if the player collides with everything. Note that this will ignore the bullet, because the bullet doesn't have the physics behavior. And then we'll add the action damage player from the health extension, and then add an action to change the width of the tiled sprite, and then we'll copy that action and put it at the beginning of scene so that it modifies the width of the sprite at the beginning of the scene as well. And the one last thing we need now is for the player to die. This specific condition comes from the health extension, and then we'll delete the player, but on top of that I'm going to create a text object called Game Over, and put that on screen, and have it hide during the beginning of the scene, and show up again when the player dies. And that's how long it takes to recreate asteroids in GDevelop. The only real problem being that the game doesn't have any sound, and it isn't very much fun to play. So in the next video, I'm going to show you how to add all the bells and whistles that make games fun to play and interesting to look at. But for now, be sure to comment down below, and tell us what kind of tutorials you would like to see next. Maybe we'll add them to the pile. I have been Helper Wesley, and I'm glad I could help. Hey there, my name is Helper Wesley, and today we'll be trying to make our Asteroids game fun to play. If you didn't see the last video, then I'm sure there's a link somewhere to it, but we ended up with what you see in front of you now. It's technically a game, but it's missing all of its life. We need to add sound effects and screen shake and particle effects and all that stuff. So let's get started. For now, when the player dies, they just get deleted. So instead we're going to create a particle effect to replace that. We're going to make sure that the ship has a minimum rotation, and that there's only one particle in tank. And we'll make sure to rotate the particle so it starts where the player stopped. And now we have a ship that kind of falls into space. And we'll use the second particle using some points to give it a little more flair. And we could definitely make our game over text look a little more impressive. So we're going to give it a custom font, this being the font that I use for everything GDevelop related. And then if I give it the glitch effect from the effects menu, it will look like this, which is certainly an improvement. Next we're going to create some debris for the asteroids for when they explode. And just like the ship, we'll be using the texture of the asteroids to make the effect. And doing this just makes it more satisfying to look at when the asteroids explode. A big problem with this game so far is the lack of player feedback, specifically when you get hit. So we're going to go to behaviors and add the flash, or blink, behavior to the project. We'll slot that action into the event where the player gets hurt. And now you can see that the player flashes when they get hit. Another aspect of player feedback would be sound effects, something that this game really needs. So we're going to open up JFXR, randomize the sound effect until we get something that we like, and then title it laser fire and save it. You may want to put in a variable for the sound here, but I'm just going to put in a hard 50 for now. For sounds that happen once in a while, you can just put 1 here, but for sounds that are going to happen over and over again, you want to have a randomized pitch. Otherwise, you're going to drive your players insane. So to randomize something, all we have to do is type in random, and it will show us our options. And I'm going to pick random float in range, and put in 0.9 and 1.1. This means that every time the sound effect is played, it will pick a number between 0.9 and 1.1 to play at. I'll slide that action over to where the laser effect is actually happening, but we're going to do this for everything in the game, which includes a collision effect when the player runs into an asteroid, and an explosion sound when the asteroids explode. And now we need just one more thing as far as effects go, and that's the camera shake. So we're going to add that to the project, and then go to the getting hurt event, and adding it as an action. And there we go. And now for a little more polish, we gave all the asteroids a bunch of animations. So we're going to go to the beginning of scene event, and use the action, change the number of the animation, and this time we're going to use random 3, because the big asteroid has 4 animations and the 0 counts as a number. And now if we start the scene, you'll see that they've all picked a different image. And now for the somewhat tedious part of tweaking things. Making sure that your collision masks make sense with the objects, and then playtesting it. And then making sure that your speeds and densities are all the way you want them. And then you playtest it again, and 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 again. And this is a bit subjective, but you keep playtesting and tweaking it until the game feels good to play. I'll make sure to put the link to the game somewhere down below, and you'll be able to pick it apart and play with it yourself. Be sure to comment down below and tell us what kind of tutorials you think we should make next. I have been Helper Wesley, and I'm glad I could help. So you want to make enemies for your game. Well, let's jump in. Beginning with the most useful tool in the entire kit, the rectangular movement behavior, which will soon, or already is, upgraded to this version. And in this version you have access to tweens, which changes the tool entirely. because now you can not only do rectangular movement, or horizontal or vertical lines, but you can also tween between them, which means you can make much more specific movement patterns for traps, platforms, enemies, and whatever this thing is in Hollow Knight. And next we have a thwomp from Mario that's being triggered by raycasting. Raycasting is basically just creating a line between 2 points and then checking for a specific object along that line. And in this case, if we go to the event sheet, we'll see that we're checking for the slammer object and starting the raycast from the center of the player, shooting it at an angle of 270 so it goes up, to a distance of 200 pixels. And when the raycast finds the slammer object, and its animation is idle, we set the animation to blink, which means that this event can't trigger again until that animation is changed to idle. And then we shake the object, wait for 0.4 seconds, and then tween it to the floor. If I go to the object and open it up, you'll see that it has 2 variables, the slam position and the start position, and they're 0 by default. But if I go to the instance properties and scroll down, you'll see that for this instance, I've changed those to something else. Because where it is now is 416 along the y-axis, and if I change its y position, you can see that 555 is where I want it to land. So those are the 2 variables that I'm using in the event. We'll be tweening to that slam position variable along the y-axis, and for the duration, we'll be using the slam position minus the starting position, so the duration is based on the distance to the ground. But that was kind of fast, so I times it by 2. And then when that tween is finished, we remove the tween, wait a second, and then start the next tween called rising. It's going back to the start position, and its duration is set to 5 times the distance, so it goes up a little slower. And then when the rising tween finishes, we do a little shake, wait 0.4 seconds, and then set it back to idle so that the first event can trigger again. So that's a single raycast coming up from the player, and using an animation change to dictate a behavior. So now we can move on to something a little more mobile. These enemies have the platformer behavior, and when they walk into a collision object, they turn around and go the other way. That much isn't complicated. When we go to the event sheet, we'll start with this event, where if the animation of the trunk enemy is walk, and they are horizontally flipped, we simulate the pressing of the right button, so they'll go right. If they aren't flipped, we simulate the pressing of the left button, so they'll go left. And to tell them to turn around, we added a point to the object, and then in the event sheet, if that point goes into the wooden wall object, the trunk enemy, if horizontally flipped, is turned back around, and if it's not horizontally flipped, then it's set to flip. And that's all you need for the back and forth movement. But this enemy can also attack you if you get in front of it, which is being done with raycasting. So in the event sheet, we have this section for player check. If the trunk is walking, and is or isn't horizontally flipped, it will cast a ray either at 180 degrees or 0 degrees from the enemy to check if the player's there. And if it finds the player, it changes the animation of that trunk enemy to attack. And then when it's set to attack, when its frames are above 8, it will fire a bullet at either 0 degrees or 180 degrees based on how it's flipped. And then when the animation finishes, it goes to idle. And then when the idle animation finishes, it goes back to walk. So there's a simple loop of walking around, and then if the player gets in the way, changing to attack, and then when the attack is finished, it goes to idle, and then when idle is finished, it goes to walk. But there's one more interaction we can do with them. My little follower object here is using the fire bullet extension so it can shoot as well. And if I shoot one of the enemies, you'll see they get hurt. And if we go to the event sheet, you'll see why. If the trunk is in collision with a bullet, delete the bullet, and then set the animation to hit. And this isn't dependent on any other animations. So whether they're walking, attacking, or idle, shooting them will switch them straight to hit. And then when the hit animation finishes, it'll go to idle. And now to step it up one more notch. This enemy has a similar behavior to the Primal Aspid, which people find to be the most annoying enemy in all of Hollow Knight. And the way that it moves is different than everything else, but it still works the same way as the trunk with its animations. The way it moves is based off of the Boyd's extension in combination with the newly updated, or will soon be updated, ellipsis movement extension. The Boids extension can be used to get objects in your game to swarm or avoid things in an intelligent way. And the ellipsis movement extension is like the rectangular movement extension, but for circles and curved shapes. So if we go to the event sheet, you'll see that the very first thing is that if the player gets within 200 pixels and the bee's animation is idle, then it's switched over to chase. And then if the bee's animation is chase and the player is still within 200 pixels, it triggers the two Boid actions to have the bee enemy come towards the player, but also avoid them, so they'll keep a healthy distance away. And then while it's in its chase animation, if you're able to get away from it, then it changes the animation back to idle and stays there. Now, if you want to continue learning how to make these kinds of game mechanics, click on this video for how to make a boss fight. Let's talk about boss fights. They come in many different forms, depending on what kind of game they're in. They can be long, short, big, small, simple, or complicated. But in this video, we're going to go over my favorite way to do a boss, in which we randomly pick attack patterns from a pre-made list, for which I use 3 numbers, or variables. Health for the boss, progression, which is a number that goes up as the boss loses health, so you can know when to add mechanics or have a second phase, and a third called behaviors, which is used to pick from that list that I mentioned earlier. So let me show you how we pick which attack pattern gets used. So here in the event sheet we have this section for behaviors. If I open one up, you'll see that I'm using a bunch of tweens in conjunction with wait actions to tell the boss to go to different points that I've put in the game. I'm using these coin objects as waypoint markers so I can send the boss around the level and create these patterns. In this pattern, the boss is tweening to the leftmost coin and then going to the coin farthest right before returning back to the center. And with all of these patterns, the boss is going to come back to the center point, so I'll know where the boss starts. And then finally, we're changing this object variable back to 0. And that object variable is what's being used to pick which pattern is done. So when a behavior is finished, that variable is set back to 0, which will then be used to randomize the behavior with this event, where we change that object variable, behavior, to equal random in range 1 to this object variable called progression. And progression is what's being done as we damage the boss. So when the boss is on full health, none of these events are triggered, so the progression variable stays at 1. So when this event triggers, the game picks between 1 and 1. Which means the first behavior will just repeat over and over and over again, but if we take this object variable called health down to 4 by picking up 2 of these crystal objects, then we add 1 to the variable progression. Now, when this randomizer event tries to pick which behavior it's going to do, it picks between 1 and 2, because now the progression variable is 2, which means now it's able to pick between this first behavior or the second behavior. And this second behavior looks like this. But when this series of actions finishes, it again sets that variable to 0 to start the process over again. And then if we pick up 2 more crystal objects and take the health down 2 more, so we trigger this event, we add 1 more to the progression variable. So now it's 3. Now we're able to pick between 1, 2, or 3. And again, when that series of actions finishes, the boss will go back to the center point and change the behavior variable to 0. But then finally, if I pick up the last remaining crystals and take its health all the way down to 0, we set the behavior variable to a number that's not going to be used for anything else, other than the death event. How you want to do the actual behaviors or death animation, that's all up to you. Personally, I like to use this system where you place waypoint markers within a fixed level so you can create complicated patterns just using tweens and the wait action. But this is just a system for picking between those behaviors, so your boss can have a little more variety and get more complicated as they lose more health. Now, if you want to learn some extensions that will help you make your game better and faster, check out this video for the top 10 extensions in GDevelop.